composition looks like and how you can identify it, and also how we're going to perform compositions. And what a composition is you guys maybe remember in your notes a couple last week during class we did a part A, B, and C. It was like part A, I want you to reflect triangle ABC, take that one and translate it, and then finally take that one and rotate it. What we're going to do is take all those separate parts and put it into one problem now, and that's called a composition. So with composition, 2 or more transformations done at the same time. So let me give you an example here. I got a rotation, I'll say 270. Okay, rotation to 270. And then you will see the composition symbol, which is, it looks like a degree symbol, but it's plopped right in the middle. All right, so that is your composition symbol. And then I'll put right next to it my lowercase r, which we know stands for reflections. Good talk, yep. And I'll just put y. We're not actually going to do this. I just want to give you a little taste of what a composition looks like. And then right next to it, in parentheses, is going to be the figure we're going to perform this composition on. So I'm just going to put triangle ABC, our classic one. Here's where it's going to get awkward for many of you. Everyone's going to say, all right, I'm going to take triangle ABC and rotate it 270. Nope. Compositions are performed right to left. Let's say that again. These are performed right to left. So again, here's how we would do this. We take triangle ABC, put it on graph paper, right? Graph it A, B, and C. Then I would reflect it over the y-axis. Wherever that triangle ends up, rotate it 270, and that's my final triangle. So that's how compositions work. You take your beginning figure, and we work right to left. All right, right to left. So let's try that out first on a single point before we get into a whole figure. So go ahead, graph point A, 3, -2. Here's point A, 3, -2. And we are going to perform the following composition on this. And again, I can see my little symbol there in the middle that says it's going to be a composition. Right to left, right to left. So I'm going to take this point and translate it -2, 4. So that tells us left 2, up 4. So left 2, 1, 2, 3, 4. Here it is. Now, I'm not going to call this A prime. We consider a composition one full transformation. All right, so at the very end, we're going to call it A prime, not in the middle. Not in the middle, because that's considered one full transformation. And then what are we going to do from this point? Rotate it 90 degrees. Which direction? Counterclockwise, because it's positive, remember. Yep, counterclockwise. All right, so everyone rotates it counterclockwise 90 degrees. And we see where that point ends up. That's the point we'll call A prime. So where does it end up here? I've done this a bunch of times. -2, 1. A prime. Don't just think it might be 2 either. I said 2 or more in the definition. If I could easily do this, add this to it. All that would mean now is we take this point and reflect it over the x-axis. So you keep going right to left no matter how many are written there, no matter how many transformations. Questions? All right, I think we're ready for a figure now. So let's try triangle TEX and graph it and perform a composition. Now I'll start asking you guys questions. right, so here we go. First question, according to the composition that's written up here, what are you going to do to the triangle first? According to that composition, what's going to be performed first up here? Here we go. Doyle, what's performed first? Let's do it. Let's reflect it over the y-axis. Again, I'm not going to call this E prime, T prime, X prime. I'm just going to plot my points. And then from there, yes, so go ahead. I didn't graph X, right? Because that's 2, 1, yep. Thanks, Zoe. Just start from scratch. I'll edit that out of the video later. I'll be honest, I have no idea how to edit, so I guess it's going to be kept in there. Better there, Zoe? Thanks. Glad I got your permission there. All right, back to my original question now. What happens to this triangle? Where's it going to go now, Ian? Where are we going?
Down 5.
Down 5, right? There's a 0 there in the x coordinate, so we're not going left or right. We're just going down 5. Then we could call it T prime, E prime, X prime. 1, 2, 3, 4, 5. And you guys that are waiting for me, notice the directions also is graph and state. Graph and state. So please label and write out what the coordinates are. All right. So we all pick up the idea of what a composition is. Last thing with it is a special type of composition, a special one. And it's called a glide reflection. What's it made up of? Translation, that's where the word glide is. Glide, translation, and a reflection. But it's not any translation and reflection mixed together. It has to follow a certain rule. And I will do you no justice up here trying to explain that rule. So the only way I'm going to have you guys figure it out with me, the first and last time, we're going to take a field trip. We're going out to the hallway. Come on out. Learn about the glide. Go on opposite sides of the hallway. Don't be shy. every time first? Can you slide first? Yeah. You can slide, but you better make sure you reflect parallel with wherever you slide. Okay. Good. Questions? Why reflection? This will be out here all week. In case you guys want to come by, put it in the crew period or something all. Pump some music up. We got some thumbs here. There you go. All right. Come out here anytime you want. You guys can involve up here. Have friends over the weekend. Pump some tunes up. Line reflection in the corner. Reflection on the other. All right. Everyone are every line reflection. All right. So back in. I'm going to look back at that triangle text again. All right, don't move on. Look back at that triangle text for me now. You didn't know it at the time. We just did a glide reflection with text. Why? Ready? Why did we do a glide reflection with triangle text? What's the first thing we did with it? Reflected it over the y-axis, and then where did we translate it? Everyone see? We translated it parallel to the line we reflected over. So this right here, from text to T prime, E prime, X prime was a glide reflection. So everyone's good. What's made up of a glide reflection? All right. Practice it on your own. All right, next up, a couple vocabulary words. First up, an orientation of a figure. Orientation. That is the direction, and I'll show you an example in a minute. Let me get the definition down. Direction of a figure's vertices. Woo! What is he talking about? All right, direction of a figure's vertices. Take my triangle. Let's label it A here, vertice B up here, and C here. Here's what I mean by orientation again. I go from A to B, B to C, C back to A. What direction am I going? And let's use terms from this unit. What direction am I going in A? Clockwise. So we would say this figure has clockwise orientation. Okay, clockwise orientation. Now, we've gone over three big transformations: reflections, translations, and rotations. Here's the challenge to you honors kids I'm putting out there. Name one of those three that I could perform on triangle ABC and the orientation would not change. Not change, meaning I perform this transformation on ABC, the direction is still clockwise. I only want one. Name one out of those three we have listed up on the board that would not change the orientation of clockwise. Josh?
Rotation.
Rotation? Would that still work? I don't know. Go. If you have this on your paper right now, turn your darn paper right now. Go ahead, turn it. And look at A to B to C. Is it still going clockwise? Yes, so that's a good one, Josh. Good. This is rotation. And I just want to go back to the beginning of the unit here. I wrote this word rigid motion. That's coming back now. That's any transformation that does not change the size or shape, right? Remains congruent. So that's why I put rigid motion. These are all rigid motions. Steve? Oh, I was just going to belt. Hey, I got a spot for another one. Josh got rid of rotation. Zeev says translation. Yeah. If you slide a figure, it's not going to change the orientation. Yep, translation. All right, now let's talk. What would change the orientation? So I do this to triangle ABC, and now it's going counterclockwise instead. What's my one remaining one up there? Reflection, and I'll show you how and show you why. Hey guys, go back to triangle text for me. I'm using that example a lot today. Go back to triangle text for me. Remember the first thing we did was a reflection. Watch. I'm just going to do this, and it's not, I know I don't want you guys to do this, but I'm just showing you for teaching purposes. TEX, what direction am I going? What's the orientation? TEX. Clockwise. Go TEX again in that same order. Now what direction am I going? You see it? Reflections change the orientation. Right? If a reflection happens, I guarantee the orientation will change. Good? Whoa, whoa! I got a spot for something else. Spot for something else? We went over all three of them. We're done. I don't have anything else. Or do we? Don't add in something new either. Something we've talked about.
Rotation.
Rotation?
Wait, can't you rotate the other way?
Good. Rotate both ways. Does it change your order of the...
Shoot. No.
Right? It doesn't. Good. Good point. Negative or positive doesn't change. All right. Negative rotations are strictly to keep the same orientation no matter what way you rotate. That's fine. Something we've done already, Matt.
Why?
Glide reflection out in the hallway, right? Because what's a glide reflection made up of? A reflection which changes orientation. Yeah. Good. Well, I translate. Doesn't matter. A reflection is involved, so that means it's going to change the orientation. Why am I harping so much on orientation? Because before you leave today and all day tomorrow, I need you to have a specific skill that involves orientation. And here's the skill I need you to have. Going forward now in this unit, you need to be able to tell me how a pre-image matches up with an image. Rotation, reflection, translation, and specifically how many degrees, up, down, left, and right. So for this one, I'm making it easy on you because I gave you multiple choice. I have pentagon ABCDE. I want to know how does it match up to the double prime one, and I've given you choices. But whoa, we're going to eliminate a couple choices right now just looking at the orientation. So everyone start with the pre-image, ABCDE. If you go in that order, what's my orientation? Which direction? From A to B to C to D to E back to A. This is clockwise. Everyone agree? Look at the image. Look at the image. A, B, C, D to E back to A. What direction am I going? Hey, so this was clockwise. This stayed clockwise. Why is that so important? Why am I harping on it? I know what it's not. I know what not happened to get from one to the other, and that is a reflection. A reflection didn't happen. Let me talk about this too, Hunter. Could two reflections happen though? Why? Because it changes and then the second one goes back to the original. So yes, two reflections may have happened, but one didn't. So I'm eliminating number 4. Why am I eliminating number 4? A reflection, and only one reflection happened. I don't care what it's followed by. All right. And then I'm also getting rid of, which one else should I get rid of? Where just one reflection happened. Choice 1 I'm getting rid of. I am not getting rid of choice 3 because this would revert back to the original orientation. Okay, so I'm going to leave it up to you guys to look at choice 2 and 3 and see which one matches the pentagons up. There it is. All right, so which one matches them up out of 2 or 3? 2, Zoe. I despise all of you. All right, let's go.
Page curl. Oh, that's already said.
If anybody has no idea what's going on, answer was 2 and I called on 2.
Slide left, slide right. How many are there?
What's that?
Star. How many votes? We have 62 people. How much of those are- Yeah, everyone gets one minute.
Am I missing something?
Then we just do back.
Am I missing something here? 1, 2, 3, 4, 5, 15 of them. Thought there was more, but we're going with these. All right, here we go. Curl. Pinwheel. Cube. If you're trying all the one apiece, I'm not going to give you all of them if you do one apiece. Shatter.
Why not? We haven't even talked about it yet, so.
Shatter. Genie. Slide right. Left. Clock. There we go. Book. Drop.
There was 2 votes for the book.
No, there wasn't.
Yeah, there was Haley and
Yeah,
Gianna.
I did vote.
Drop. Fade. Wipe. Curtains. Swing. Star. Star. Fine. I'm just gonna rub it all in your. I'll give you. Sure. I'll give them all. I'm just gonna rub it right all in your faces too when it doesn't happen. All right. Your whole magic trick here. All right. So you got clock, book, drop, swing, and star. All right. Clock, book, drop, swing, and Promethean person. All right, here you go. You got 5 right now. You're still not going to get them all.
You just said we had star though.
Oh, I guess I was wrong. Sorry. All right, we ready for it not to happen? I still have more slides. Yep. All right, clock, book, drop, swing, Promethean person. We ready? Oh, flip. Not even nominated. How's that feel? Or did we not ever see that one either, right? We've never seen flip before. Let me guess, right? Get out of here. That's what I thought. Yep. Come stronger next time. Okay, we're all good here? All right, and I don't care if one of your choices comes up next. You're lost already, all right? So, Genie. Yeah. Did we even have that one? We got Genie on there. Oh, yeah. All right. Next up, let's keep getting better at this. This is the skill I was talking about. You have to be able to carry one figure onto another. So how do I get ABC onto RST? Which rigid motion will prove them congruent? All right, ABC. What's the orientation on ABC? ABC? Counterclockwise. All right, I know now. Look, I don't have A prime, B prime, C prime, do I? But I have a congruent statement, so you know what A, B, and C should match up to. So now look, RST. Which direction are we looking at RST? RST, anybody? RST. Also counterclockwise, so I'm getting rid of anything that has one reflection. I can't get rid of 4. I can get rid of 3, and I can get rid of 1. No way it can be those. It should have changed the orientation if it was one of those. So let's look at number 4 right now. Is it a line reflection over the x-axis followed by a line reflection over y equals 1? I don't know. Let's check. I'll take point C into it. All right, so point C, if I reflect it over the x-axis, it ends up here. And can you guys remind me what type of line is y equals 1? Y equals 1, that's a horizontal line. So right now where my green point is, I need to reflect it over that line. No way is that going to match up with T, is it? All right, so it can't be that. But I do want to go over why it is choice 2 other than just saying it's process of elimination. That little turn trick I've been teaching you guys for rotation only works if we rotate around the origin, 0, 0. It doesn't work for any other, like this one, when I rotate around 1, 0, which is right here. But how do I know this is still works? What's 180 again? I know it's degrees in a triangle, but isn't it also a straight line? Degree measure in a line. Watch. Connect A to R. If I connect A to R, going through that center, oh, I find myself out with a straight line there. That's 180 degrees. And same thing can be said if we do it, let's go B to S, right? B and S should match up. Look at that. All right, directly on the opposite side. All right, so that's why it's 180 degrees around 1, 0. All right, hand holding is done. Goodbye to the multiple choices. Now it's on you. Now it is on you. Ooh, 2 in a row, huh? Now it's on you to figure it out. How do I get A, B, C, D onto that trapezoid, the double prime one? Make it easy on yourself, please. I'm hoping you're hearing my advice. A, B, C, D, what direction we going? Orientation is counterclockwise. Good call. What about the double prime version? That is also counterclockwise. So no one should be giving me one reflection. Can you give me 2? Sure, you can give me 2. And the very last thing I'll tell you before I let you go on your own, your rule has to work for all the vertices. If you find a rule that works for A to A double prime, you better check the others then. All right, because you could have a rule that works from A to A double prime but doesn't work for B and B double prime. Okay, so your rule has to work for all vertices on the graph. I'll give you guys a few minutes. You can write it out in words, your rule, or you can write it in the new composition notation that we have. All right, but your rule better work for all 4 of those vertices, not just one. A has to go to A double prime. B has to go to B double prime. You can write it out in words what your rule is, or composition notation like we showed at the beginning of class. You had almost a third of the options of the slide transitions and you still couldn't get it. You have a 33% chance. Or you had 5, including the Promethean person. Doesn't look good for the year.
So are the odds of the Promethean person coming up like lower than like?
I don't know. It's random. Okay, I will say it hasn't come up in a while. Well, here's the problem too. Is I do slide transitions for every class. You and my honors classes are the only ones I put no homework on, but like 7th period, I teach a senior class, so it could pop up there. Yeah, so it's just not because of you guys. I do it 4 other times during the course of the day. It's just I do the no homework thing just with you guys. Okay, so here I will put up, and I want to make sure I emphasize this, there's multiple ways of doing this. Multiple ways. And also, don't think you just have to do 2. If 3 gets the job, 3 transformations get the job done, then so be it. It's 3. All right, it's just not, and it could be 1 too. For I think this one you could do it in 1 as well. But I will put up the most popular one, and then I would love to hear from anybody else that did not have the most popular one. And I say the most popular one because it's mine. Right? But this is what I've heard most times over the years is this one. But all right, so here's how I matched them up. Maybe a majority of you matched them up this way. We'll see. If you didn't, I still want to hear it to make sure it's correct. So I did a rotation. That word's not good enough. If you're going to put that word, you better have it with a degree measure as well. All right, so rotation of 180 degrees, and that's not even good enough. Around where? Right, because we just showed it's not always around the origin. So in this case it is though. So rotation of 180 about the origin or around the origin, followed by a translation down 2. And again, that's mine. I'm telling you, there's at least 2 others out there. 3rd period, there was at least 2 more that got brought to my attention. Before I ask you guys yours, If you want to do this in composition notation, whatever you do first, remember, has to be on the very right. So I got to put my rotational 180 on the right, and then my translation, whether it's in vector or this notation, on the left. And finally, in parentheses, what we're doing it on. Don't forget that. You just can't leave it, what the heck are we doing this composition on? A, B, C, D. All right, here we go. Others that would have worked. Doyle.
Rotation of 180 degrees centered at 0, -1.
0, -1. Yes, that's how you could do it in one move. If your center of rotation is through 0, -1, correct. All right, again, that works if you do slope, down 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It lands up on A prime. Yep. Did anybody have the combination where one of them was a reflection over y equals -1? Is that? Yep. So if you had that one, correct. I noticed Z did 2 reflections. That's okay, because that doesn't affect orientation. 1 reflection does. Those are the 3 popular ones. Anything else I'm missing? Did anybody do it in 3? Because you could do over X over Y and then down 2.
Over X, down 2.
Yeah, and just so you guys are aware, anytime you do reflected over both axes, and I don't care, if you're interested or not, anytime you reflect over both axes, that's the same as a rotational 180 always. So something you can impress your friends with if you have any later. All right, one more. What, Matt?
Wait, have you said reflection over y, -1?
Yeah, we did. Good, Matt. Good job, everybody. Man, good job. Anybody else going? One more. One doesn't make you great. See if you can do this one on your own. A, B, C to D, E, F. Check out the orientation first. I'll do it with you. Let's see. A, B, C, that's going counterclockwise. And D, E, F, also going counterclockwise. So we should not have a single reflection. You can have 2, though, but you cannot have a single reflection. You'll change its orientation. Let's see what we got here. Make sure it works for all 3 vertices, not just A to D. Words or composition notation is fine. All right, I'll go over my way. Any other additional ones? I'll just save time with you guys here. I'll do it in composition notation, but I could have written this out in words. All right, here's what I'm doing first. I'm doing a reflection through the y-axis first. And again, we're doing this on triangle ABC. And then after I reflect through the y-axis, we're going to reflect through the horizontal line, y equals 2. horizontal line. Others that may have done it, and did anybody have another reflection through another point and did it in one step? So I think that was, I can't remember what the point is, but you could rotate 180 around a different point, 0, 1, no, 0, 2. I think it was 0, 2, 0, 2 maybe. You could have rotated it around. Okay. Anything else? Okay, good deal.